College London, and co-leads the Marginalised Communities Programme at the ESRC Centre for Society and Mental Health. A quantitative researcher specialising in population mental health, her work uses large-scale longitudinal and survey data to examine social determinants of mental health and inequalities in access to care. Her research focuses on using statistical methods to better understand mental health disparities and inform equitable policy and practice. Latent class analysis is a powerful statistical method for uncovering hidden subgroups in populations, widely used across social and health services. This introductory seminar will provide a clear and accessible overview of what latent class analysis is, why researchers use it, and how it can be applied in practice. And I'll now hand over to Rebecca for her presentation. Thank you, Rebecca.
Yeah, thank you, Ginny. That was an amazing introduction. Bear with me, everyone, where I just try and share my slides, and hopefully this will work. Can everyone see those okay? Can I get a thumbs up? Wonderful, yes. Fantastic. Okay, so welcome everyone to this 1 hour sort of gentle introduction to what latent class analysis is. Just to sort of echo the introduction that Ginny gave, so I'm a lecturer here at King's. I'm a lecturer in society and mental health. I'm based not only in the Centre for Society and Mental Health, I'm also based at psychological medicine. My background is in social statistics. That's what my PhD is in. So I do a lot of analysis of survey data and cohort data and hospital statistics. My current research sort of focuses on population mental health and with quite a big focus on health inequalities, particularly in relation to ethnicity. And I've also done a lot of work focusing on the sort of well-being of the healthcare workforce in this country. Now, I'm hoping that Menti behaves himself, but I'd love to start with a quick check-in from our audience, just to get a sense of where everyone's coming from, what people would like to get out of this, how people currently feel about latent class analysis. If you could join the Menti, that would be amazing. If you could just go to menti.com and put in that code or scan the QR code with your phone, that'd be great. And I'll just hold on here for a second and I watch. Oh, amazing. Thank you, everyone. I watch people just slowly trickle in. Amazing. Maybe we'll move on then. We've got 31 people have managed to join. 32, we're almost there. 33. Oh, okay. I think that's about right. The code will stay at the top for the Menti if you want to join in a minute. And I just want to ask you a few quick questions. There we go. I'd love to know how you feel about statistics. So if you could plot where you are on this graph, that would be amazing. At the bottom, we have I hate it and I love it. And at the y-axis on the left, we've got no experience and lots of experience. So it's good to get a sense of where people are. Oh, people love it. This is amazing. Wow. Oh, we've got a few experts. Amazing. But a great spread. This is really interesting. Great. Oh, some people do not, 1 or 2 people don't like it. Most people love it. And we've got a sort of mix of experience, a lot of people in the middle. Brilliant. Okay. And some people really love it and have no experience. That's also fine. This is perfect. This is exactly what I was hoping for. I think most people have done that. Now I'm going to move on to the next slide. So what do you know about latent class analysis? And it's completely fine if you have no idea what I'm talking about and you've never heard of it before, that's absolutely fine. A lot of people have heard of it, great. Some have used it, some haven't heard of it. Was sort of hoping someone would go for the I should be teaching this section and I could just chill out for the next hour. Okay, perfect, okay. This is good. This is perfect. This is what I was I think you're in the right place, guys. I wanted sort of people that maybe haven't heard of it or have heard of it a bit, but maybe not used it that much. Sense of, how confident you feel using it. If you were to go away right now and sort of have a go at trying to use latent class analysis, how confident would you feel going away, sort of firing up Stack Overflow and Google and trying to find out how to do it? Okay. This is good. This is good. I'll check in at the end to see if I've moved the dial at all, but this is good. Okay, to know where you all are. And then finally, we won't do any more than Menti now until the very end. Finally, what made you attend this session today? Are you curious about this method? Is it something you want to do in your own research? Is it something you've done a while ago and you just want a bit of a refresher? You just hear the memes. There will be memes throughout. I'm a millennial, I can't help myself. A lot of people keen to use it. Some people are just curious. That's absolutely cool. All right, looking good. Okay, let's make a start then. Thank you so much. Right, so good news, you're all in the right place. The aim of this session is to provide a very gentle sort of primer introduction to latent class analysis. I'm assuming no prior knowledge, although some of you clearly do have some experience of using it. I want to try and explain its purpose and its applications, and hopefully at the end of this session, you'll have a basic understanding of what it is, you'll understand why and when researchers use it, and hopefully that will improve your confidence to go ahead and use it yourself. So, rough schedule for the next hour, I'm going to provide a very gentle introduction to LCA. I'm going to give some brief real-world examples of how it's been used, and I'm going to take you through step by step to do it. So let's make a start. What is latent class analysis? And before I can actually give you an answer to that question, we need to go through some key concepts. We need to go through clustering, we need to go through latent variables, and we need to go through categorical latent variables, i.e. classes. Break each one of those down right now. Concept one, clustering. When I say clustering, I literally just mean grouping people together based on a shared set of similar characteristics. In health research, we might do this by sort of grouping people by their sleeping habits, by their goals. And in doing this, it makes it much easier for us to understand big data sets. It allows us to see differences and similarities between groups of people and find trends that may not have been entirely obvious straight away, especially if you are using big complex data. Let me sort of give you an example. Imagine we're all teachers and we want a group of students and we give them practicals and we want to sort of group them up into groups that maybe are similar to each other. Our thinking is that if we group similar students together, maybe they'll get on better and do the practical well, hopefully. And so we might want to ask them questions to get a sense of who they are. And so hypothetically, we ask them on a scale of 1 to 10, how much do you love the morning? And on a scale of 1 to 10, how many cups of coffee do you drink in a day? And we may get all that information and plot it with how much they love the morning on the y-axis on the left there and how many cups of coffee they have in a day at the bottom there. And each dot will just represent a response to those two questions in the same sort of way that we did earlier on with the Menti. So you may start off with a sort of big, messy plot like this that's just a bunch of dots on a grid, not very useful. But then you might look at it and notice clusters of people that have some similar responses. And the more you look at them and try and figure out what that means, you may be able to sort of group them and name them better. For example, you have this sort of blue group at the bottom who don't like the morning at all and don't drink many cups of coffee in a day. So maybe they're night owls. You have the green group in the middle there who certainly seem to like the morning a lot more and they drink a moderate amount of coffee and maybe they are early risers. And you have these lunatics on the right here who hate the morning but adore coffee and drink insane amounts during the day. Maybe they're coffee addicts. And so very quickly, we've gone from this sort of messy plot that's not very helpful to sort of finding groups of people that are similar and understanding who they are. And so that's what I mean by clustering. Concept two, what is a latent variable? And this is the key, really. Once you get your head around this, the rest is pretty straightforward. What is a latent variable? Sometimes we cannot measure things directly. This happens a lot in psychology, it happens a lot in sociology, a lot in mental health studies. A latent variable is something that we cannot directly see or measure, but we believe it exists because it does influence things that we can observe, which is why I quite like this example of the sort of funky retro ghost. We can't see the ghost, but we know the ghost is there because it's moving the bedsheet. So that's kind of what a latent variable is. I think to understand what a latent variable is, it helps to understand what a latent variable isn't. So things like blood pressure, height, weight, and body temperature are all things that we can measure directly. We can measure them with scales, with a thermometer, with a measuring tape. So these are not latent variables, they're called manifest variables. Let's give an example of a latent variable. And one of the most sort of obvious ones, particularly for the field of sort of healthy research, is mental well-being. You cannot directly see or measure someone's mental well-being, but you can ask them questions like, do you feel happy most of the time? Do you have the energy that you need to do your daily activities? Do you feel calm and relaxed? And if someone says yes to all of these questions, we may infer that they have great mental health. And if they say no to these, if they score low, for example, on these questions, we might infer that they have quite poor mental health. In keeping with this sort of mental health example of latent variables, depression is a latent variable. You can't sort of go up to someone with a measuring tape and determine if they're depressed that way. Depression also affects lots of different things, impacts lots of different things. So depressed people sort of may have negative thought patterns, they may have altered moods, they may feel sad or empty. Depression can put a strain on people's social relationships. Maybe you don't hang out with your friends as much. It can change your behavior in that you withdraw not only from social activities, but maybe from activities that in the past have brought you joy. And it can lead to physical symptoms like fatigue, sleep disturbances, appetite changes, and things like that. And so if you want to find out if someone's depressed, you could ask them all of these questions. And you could take those responses and plot them on a line here, where maybe you have some people on the left who are very, very depressed, some people on the right, sorry, other way around, some people on the left who are not depressed, some people on the right who are very depressed, and most people will be somewhere in the middle. And that's sort of one way of understanding or conceptualizing a latent concept like depression. If you are interested in a bit more in this, which is slightly different from latent class analysis, do let me know afterwards. You can use methods like factor analysis, for example, to learn a bit more about this. But let's not dwell on that. Moving on to the final thing, what is a latent class? And this sort of brings it all together. Sometimes a latent variable is not continuous. Sometimes latent variables are just better understood as categories rather than points on a scale. So instead of thinking in terms of more or less of something, sometimes it's better or more appropriate or more accurate to understand things in terms of distinct types. Keeping with the example of depression, for example, it could be useful to think of people on a spectrum, people who are low, medium, or high depressed, but it might be more appropriate to think of how people fall into distinct groups. There may be a group of people in your data set, for example, who have atypical depression, or a group of people who experience bipolar disorder, or a group of people who experience seasonal affective. Another example that I quite like, personality type. Imagine we collect survey data on a big group of people and we ask them about their social behavior, their energy levels, and their group preferences. And depending on how they respond, they may fall into one of three personality types: introverts, extroverts, and ambiverts. So for example, people may be classed as introverts if they said that they had low social behavior, they have low energy levels, and they prefer alone time. That would be me. And people may be classed as extroverts if they say that they have high social behavior, high energy levels, and prefer larger groups. And you may be classed as an ambivert if you're somewhere sort of in the middle. And so that's kind of what a latent class is. It's a sort of hidden group in a population that you can identify based on patterns in observed data, just like those sort of questions that we ask them. The important thing to remember is that latent classes are meaningfully different from each other because they represent distinct groups with different patterns or responses or behaviours. And unlike a continuous variable where differences are plotted along a spectrum like we did with the depression severity example, latent classes suggest that individuals belong to separate and meaningfully different categories. And now we can finally go back to that initial question that I asked you all. What is latent class analysis? It is a statistical method used to identify different hidden subgroups within populations that often share certain characteristics. It is a way of taking sort of rich, big, complicated data, applying this method and finding hidden, interesting, meaningful subgroups that reflect the latent variable that you're interested in. Why do we do this? Why is this useful? Like I've said, it's really good at looking at patterns and raw data that aren't immediately obvious. And that can be very helpful if you're doing any sort of health research, for example. You can group people according to their sort of health behaviours or their needs or different mental health symptoms, for example. And that will help us to improve our understanding of a population's health, mental health, physical health, and indeed guide interventions tailored to those specific groups that you find throughout your analysis. I'm going to very quickly go through some interesting examples of how this has been used. I've got 3 examples here. This is the first one, and this one is looking at sort of coexisting symptoms of different mental health disorders. That's the thing. So that the coexisting mental health symptoms is sort of the latent variable here. So they're trying to examine comorbidity in mental health problems in adolescents. So they use a sample of around 10,000 adolescents aged between 13 and 18 in America. And the indicators that they're using to find these groups are symptoms of mental health disorders. And they found 3 latent classes. One of them was an emotional disorder class, one was a behavioural disorder class, and one is a normative class. Those who belong to or have a high probability of belonging to the emotional disorder class, probability of having anxiety and depressive symptoms or disorders. Those in the behavioural disorder group have a high probability of reporting substance misuse, major depression, and behavioural disorders. And the normative class have a very low probability of having mental health problems. But what's interesting in latent class analysis is you can not only find these classes, but then you can look at the people that tend to have a high chance of being in them. For example, in the emotional disorders class, women tend to have a high probability of being in that class or in this study. And this tended to be people who had a lot of family instability and parents with very low education. In the behavioural disorder class, this was most commonly boys who tended to come from urban environments and had a lot of social disadvantage. And this is quite useful because it can be used to identify people at risk early on based on their symptom patterns. And the paper did actually say this potentially is quite an interesting and useful way for schools and children's health services to do a sort of data-driven sort of method to screen and identify those at risk. Moving on to our second example, and addiction was the sort of a latent variable that they were interested in. They wanted to find groups of people with different sort of addictions. So they used a huge survey of over 40,000 people and the National EPI Survey of Alcohol and Related Conditions, and they use reported drug use as their indicators. And they found 5 different classes of people. Some classes had a high chance of displaying polysubstance use or addiction to prescription drugs or stimulants and hallucinogenics. And what the study found was that each class had a very unique mental health challenges and completely different socio-demographic profile. So it's not only useful to find out that these different groups sort of exist and who they are, but what their mental health needs are as well. Finally, this small study looked at lifestyle, like healthy lifestyle was sort of their latent variable. So they had a small sample of around 2,000 undergraduate students from a large American university, and their indicators were things like sleep, stress, drinking, weight, risk-taking, things like that. And they actually found 8 classes. And there was a huge gender divide in the findings of this study. So they broadly found 4 that were entirely female and 4 that belonged to entirely male participants. And I'm sort of oversimplifying this a little bit, but broadly speaking, the classes that for the male classes tended to display more sort of dangerous, risky behaviours, and not so much in the female classes that were sort of moderate sort of health styles. I will say this is probably a very specific study. It's a very small sample of undergraduates in a very specific university in America. And reading it, I do think the way they've talked about gender is kind of outdated, but it's interesting to find how basically there's not like a one-size-fits-all approach when you're trying to improve people's lifestyle. And they do go on to say this, that many people face multiple interconnected health risks, and potentially there is a need for a more gender-sensitive, lifestyle-focused public health policies. And broadly speaking, that a one-size-fits-all initiative to sort of improve people's health and well-being might not be very effective. Now, this is where I pause, because I've been talking now for about 20 minutes. And I just want to pause here and quickly give a recap on what we've covered so far. So we've covered what latent class analysis is. It's a method to identify unobserved latent subgroups within a population. It helps us to uncover patterns that are not immediately visible, can be very helpful. We've covered key concepts like clustering, where we group people together who are similar, latent variables, which are unobserved traits that we infer from observed data. And we've covered classes, which are discrete groups that reflect a latent variable. And I've given you some examples here that show that identifying hidden subgroups according to different sort of mental health profiles and risky behaviours can be quite useful and help to potentially tailor interventions and policies to specific population needs. And I want to just quickly check in if there's anything that I've covered that people have a query about, I want to ask a quick question. If everyone's fine, feel free to just use the reactions and give me a thumbs up if you're all cool so far. We will have a Q&A at the end, but if there's anything that people would just want to flag right now, that's totally fine. A couple of thumbs up. Okay. Like I said, there will be a Q&A at the end, so let's press on. There we go. So now I'm going to talk about how to make a latent class model. I'm just going to take you through sort of step-by-step of a typical LCA, the process of making a typical latent class analysis model in an exploratory way. I will preface this by saying that latent class models can be very complicated and lots of different types of latent class analysis. What I'm going through here is just a very sort of basic, simple way of doing a sort of typical latent class analysis model. So broadly speaking, there are sort of 5 steps. Step 1, decide what the latent variable is that you're trying to measure. Step 2, get your data. Step 3, fit the model and evaluate model fit, which is very important. 4, time, decide on the number of classes that you want for your model. And 5, interpret the final selected model. Let's go through those now. Here come the memes. You have to have a very good understanding of the latent variable that you're trying to understand. And I sort of say that because sometimes with latent class analysis, it's very tempting just to sort of put in lots of data, run the model, and just see what comes out. And the problem is it's a bit more complicated than that. And if you do that, you might make something that's hard to interpret and isn't very useful. So it's not about simply just clustering groups of people. You have to have a very good understanding of depression, if that's something that you're interested in looking at, or mental well-being, or personality types, or anything like that. Look at the theory surrounding that particular topic, read what other people have done, make sure you understand what you're researching. And having this sort of strong theoretical understanding will make it much easier for the next step when you sort of pick your raters, when you identify the classes, and when you interpret your results. So it's just good to really focus on step 1 and get a good understanding of what you want to study. Step 2. So you understand now what it is you want to study, and now you have to get your data. And for some people doing this might be straightforward, it might be data you already have. But I do want to do a quick shout out to the UK Data Service, because in this country we have some amazing rich survey data. We have lots of incredible birth cohorts that are run by the Centre for Longitudinal Studies that are really rich and follow people in their lives. We have Islamic Society, which is a huge cohort in this country. We at King's, for example, have access to clinical records, Chris. So the idea here is that you sort of assess what data is available and open to you, and which data sets have the best indicators that affect your latent variable, because you're going to be using them in your latent class model. Sometimes it's a slight compromise, but it's just about finding the most suitable data set for you that has the most appropriate indicators for your latent variable. Step 3, fit your model and evaluate model fit. So I will sort of just say here, when you come to fit your model, there are lots of different software packages that you can use to do this. The most common ones are Stata, M+, and R. I imagine a lot of people here are probably most familiar with Stata. That tends to be very commonly used. I would sort of dissuade people from doing latent class analysis in Stata. It's fine, but it is not very well optimized for latent class analysis, so it can take a long time to produce your model. There are limits to how sort of fiddly you can get with it. It doesn't always give you as much information as that you would like. The gold standard is M+. M+ is great. It's a very powerful structural equation modeling piece of software that's sort of run by nerds. It's incredible. It is very expensive, so that might not be accessible to everyone. R is amazing and is free, and there are lots of packages in R that will help you to do not just LCA, but also structural equation modeling and also sort of cleaning your data. So if anyone was to sort of ask me, gun to my head, which software should you use, I would always recommend R. Anyway, moving on to evaluating model fit. Now, some of you may know this if you've had stats experience before, but broadly speaking, model fit is how well the statistical model that we built matches the data that we're using. Try to think of it as trying on a jumper. You want to find a jumper that fits properly. You don't want something that's too big or too small. And the way that we assess if the model fits the data well is something called goodness of fit statistics. These are the tools we use to measure how good the fit is. And there are loads of them. It's very easy to sort of get overwhelmed with the amount. If you read publications about latent class analysis, you will see that people have used things like entropy, likelihood ratio testing, low Mendel-Rubin, information criterion. And the reason that they use quite a lot is because, one, there are so many, but also two, they all sort of do slightly different things. They're all sort of getting at the same thing. They all want to assess model fit, but some really penalize models that are too complicated, or maybe that are missing important details, or that are too simple. We're going to run with one quick example called Bayesian Information Criterion, BIC, which is a great goodness of fit measure and is, I would say, the most commonly used. I haven't really come across an LCA paper that hasn't used this. The idea is that it compares the fit of the model to other potential models. And the main thing it does is penalize something called overfitting, which is bad. Overfitting is when the model sort of fits the data too well. So it sort of is accidentally picking up on maybe quirks or random noise within a data set. And it fits that data set so well that it doesn't really work on any other data. And so the findings that you're getting are very specific to the data that you're using, which is bad because you do want your findings to be somewhat generalizable. But all you need to take away from this is that in LCA, a lower information criterion suggests a better balance between how well the model fits the data and how simple the class the model is. So now you need to decide on the number of classes that go in your model. I always think this is a bit strange with the LCA, but the standard procedure for conducting a sort of exploratory latent class analysis is that you conduct models in sequence. So you start with a one-class model, and then you will increase by one class. So you'll do a two-class model, and then a three-class, and a four-class, and a five-class, and so on. And so you have all of this sequence of models, and you assess model fit for each one to see which one fits the best. This will make a bit more sense here. So typically speaking, when you add a class, the fit will improve. Until you get to sort of like the sweet spot, the optimal solution. And then the more classes you add, you're sort of making the model needlessly complex. And so that sort of makes it not fit the data as well. So for example, in the figure here, where information criterion is on the y-axis on the left, and you've got a number of classes on the bottom on the x-axis here. Remember, the lower the information criterion, the better. So it's my cursor. But you start off with a one-class model. Pretty rubbish model fit, not great. You add another class and the information criteria comes down, which is great. So this is starting to fit the data better, fantastic. You add another class, so you've got a three-class model now, brilliant, getting even better. 4-class model, fantastic, really low information criterion, great. You add another class, but then it starts to go up again, which is not great. So this is, and then you add another class, you got a 6-class model now, and it gets even worse. So this sort of suggests to me, this sort of elbow here suggests to me that the 4-class model fits the best. And so typically you would look at other goodness of fit statistics just to see if they're also saying the same thing, and you compile maybe like 3 or 4 of them just to sort of get enough evidence to say this is clearly the most appropriate model. I do want to say, though, it's not always that straightforward. That you should also sort of factor in other things. It's obviously incredibly important that you look into the goodness of fit measures that are available, but you also need to think about parsimony. That's an important thing. Like, is this a nice, simple, neat model? Does this reflect the theory that I'm now familiar with because I did all this research early on? Does this sort of reflect what other people have done? So it's very important to think of this as well. For example, maybe the goodness statistics are saying that a 4-class model is great, but then maybe the 3-class makes more sense. It reflects theory better. It reflects what other people have done better. Maybe this is easier to interpret. Maybe this is more useful. And so you could also make an argument for maybe doing a 3-class. You just need to remember to ask yourself, what model makes sense? Can I understand, interpret, and describe classes, and like how big are they? Does this make sense? Interpret the final selected model. This is when you sort of look at your classes, look at the response patterns of the people in them, and sort of interpret them and name them and sort of get your head around them, sort of like what we did earlier on, for example, with the sort of night owls, coffee addicts, and early risers. Let's go through an example now. Saying this phrase of imagine we asked a bunch of people, for like all I imagine about is asking people survey questions. But imagine we asked a group of people if they liked mosh big concerts, and we have a 3-class model. And you look at class 1, and this class don't like big concerts or mosh pits. You look at class 2, and these people like both big concerts and mosh pits. And you look at class 3, and these people do not like big concerts, but they love mosh pits. So thinking that through, you might want to name these. Class 1 is people who just don't like concerts. Class 2, maybe Taylor Swift fans. I assume that people mosh in Taylor Swift concerts, not sure. And then class 3, maybe sort of heavy metal fans who love mosh pits, but aren't keen on sort of big concerts. So in doing that, you've sort of helped understand what the data is telling you, interpret it. And this helps you when you're sort of writing out your findings, writing your discussion, thinking of implications and things like that. But there was a common problem in latent class analysis called naming fallacy, where people maybe, I know we've done some fun names here and stuff, but some people do sort of name their latent classes in a way that maybe is quite quirky or eye-catching, or reveals some sort of bias that they have, or is maybe an initial interpretation that the person doing the analysis had. And if it's not quite accurate, that name sort of sticks. And it means that it influences how you interpret that class. It influences the implications you write up. It could potentially go on to negatively influence policy if people are making policy decisions based on the research that you've done. So what often happens, unfortunately, you don't always get to give them quirky names, but they tend to be quite dry, quite accurate, just to avoid naming fallacy. So just something to be aware of when you're finally naming your classes. And we've done it, I think, roughly on time. We're at the end of the talk now. I just have to ask you once again, I'm afraid, if you wouldn't mind going back to the Menti and telling me now how you feel confident about using LCA. If after this talk you would sort of go ahead on your own with the resources that I will give you an information sheet to go forward and sort of have a crack at doing this yourself or learning a bit more about it, how would you feel? Oh, this is already looking much better. Thank you, everyone. Oh, wonderful. A few people are totally confident. Amazing. Just give that another minute. Wonderful. This is already looking much better than 40 minutes ago. So fantastic. I will say as well in the chat, I'm going to add just a one-page PDF that very briefly sort of goes over the stuff we've covered in this talk, and a reading list as well of like 4, I think some are books, some are chapters, and some are academic articles that I found really useful when I was learning about LCA and when I've ever needed to refresh it that are really interesting. So I'll pop that in the chat in a minute. And just to end here, I just want to say a big thank you for listening to me talk about LCA, and just to sort of give you an opportunity to give feedback, which would be greatly appreciated. I'm actually sort of amended this from a talk from master's student that I've just shortened a bit and amended for this session. So if you do have any feedback or suggestions or queries or want to know more about LCA or anything like that, please do use the feedback form. Appreciated. And I will leave it there and open up for any questions that people have.
Thank you so much, Rebecca. Incredibly interesting talk, and some, really complicated ideas made very straightforward for us. So thank you very much for doing that.